Might lose a finger. All right. Now, we left the question trying to... Tiffany?
We left the question, what does that even mean?
Exactly. And Max wants to know, I want to know. And most importantly, I want to share with you a story that happened during this checkup. I wasn't there for it. But my wife, being statistically minded too, was able to jump on and correct the healthcare practitioner working with her. So anyway, the question is, Max, we know Max is in the 80th percentile for weight. And we've got a theory about what that means, but the question is, how much does he actually weigh? This is raw data, extraordinarily hard to look at. This is the same data, but now I think it's not as hard to look at, huh? It's not as hard to look at anymore, because now it's essentially a dot plot. Essentially. We've got a histogram, but I've broken it down by increments of 1. So 20 pounders, 21 pounders, 22 pounders, 23, 24, and 25 pounders. Fair with me so far? Yep. Good. So it's, if you will, it's kind of the perfect histogram of raw and grouped mixed together. It's technically raw data, because there are, 3 20-pounders, 1 21-pounder, 2 22-pounders, and so forth, up to, it looks like, maybe 1 33-pounder up there. Fair enough? So, here's what I want to do first. Describe that data for me. If you had to describe that data in a couple words, how would you describe it? How would you describe it?
Skewed to the left.
Skewed a little bit. I like that, Tim. It is skewed. I think it's skewed a smidge. We could use the PSSC to calculate how much. I wouldn't ask you to do that. I think it's more important to realize that it is a little bit skewed, isn't it? It's a smidge skewed. It looks like it's leaning that way, which means the average is going to be pulled down this way. So I'd be careful using the average to talk about average weight in this case because of that very reason. Because of the presence of these low values might be outliers, and we might want to be careful about using the average in that case. Good. Where do you think the average would be? If you had to pick an average weight for these boys? 28 and a half, somewhere in there? Somewhere about here? I like that. No, what are you saying, Tiff?
I want a little bit closer to 27.
You're down here?
Yeah.
Okay, maybe somewhere in this area. It's definitely to the left of where the mode is, isn't it? Right? Your mode's going to be over here at 30 pounds, based on this sample anyway. John?
Would that be the 100th percentile is the mode?
Good, it's a great question. Let's come back to it.
Okay.
Now, you got to remember.
No, 33 would be.
You got to remember this. You can define percentile any way you want to. I'm trying to give you guys the definition of percentile that's actually used the most in the world. So I'll give you a modal definition, not necessarily the mode consistent of the mode, but the modal definition. We'll come back to that. Hold that thought. So the average is going to be somewhere in here-ish. Your mode's definitely up there around 30. Okay, we'll get to the median in a second. What I want to do, though, is I want to ask you guys a couple questions. How many of the kids in this sample weigh less than 26 pounds? Or fewer. It'll be fewer, no, it'll be less because it's a measurement.
Are you counting 26 in there?
No, just do strictly less than, Danielle. Thank you very much, great question. We're not counting 26, just go strictly less than. Strictly less than. Going for 20? 21.
I see 22.
22.
I see 23.
23! Right here, 24! I don't know, let's count. So we got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, plus 8. I get 20. Is that fair? That's strictly less than. So in other words, 20% of the sample weighs less than 26 pounds. Fair enough? So in other words, saying it a different way, 1 in 5 of the kids sampled was in that low range, if you will. That's called a, what the hell is that called? A quintile. That 26 pounds would be the first quintile, which would separate the lowest 20% from the rest of them. Fair enough so far? Keep that in the back of your mind for right now. We'll come back to quintiles. I like them, and so does the government when they report stuff.
Is it quintile or quartile?
Quintile. I'm actually using quintile because it's 20% versus 25%. Very nice, Danny. Quartiles are much more commonly used. But for that would be a quintile because it's only 20. Good, thank you, sister. All right, you ready? Same question. But now go less than 29 pounds. Now go less than 29 pounds.
40.
About 40? You're in 30s over there? Counting's just a pain in the ass, isn't it? Let's figure it out.
We already know that.
We know it's 20 to here.
Yes.
So let's add 9 more to get 29. Let's add 7 more to get 36. And then let's add 13 more
Yeah.
to get 49?
Yep.
Yeah.
49! So ish half of them. We just found, what did we just find essentially? Which means we found the
50%.
median, the 50th percentile, which is the median. Good, we just found the median. We just found the dividing weight between the lower half and the upper half of these kids' weights. Isn't that by definition the median?
Sure.
It is, isn't it? That's how we define the median. The median, if you put them in order like we just did, the dividing weight between the upper and lower. Now, technically speaking, I guess it would be in the 29. It would be in the 29, correct? Because we hit 49 here, so 50 and 51 would be in here. But arguably, we found the median by finding where half of the weights are. Fair enough? Believable? Okay, you ready?
I'm laughing because I keep struggling with like, okay, median, like the terminology.
I
and
know.
I just went, okay, so median is the thing that divides the road in half.
It is.
So
You wrote that
that's
down in your
how-
notes. That's awesome.
Yeah, that's what I've heard.
That's good. Well, actually, I love the fact that that's called that. Because that's actually what we do. It divides the road if the road is increased left to right. You know, it does divide the road in half. Just like in a triangle, the exact same thing happens. You draw to the midpoint of the side. It's the geographic location center. So, hopefully,
So that'll-
isotopes, I don't know what that is.
What else triangles called?
Isosceles?
Isosceles.
Oh, any triangle has medians. Oh, there's some neat stuff that happens with medians. They're beautiful. I wrote a paper on a few years ago. You ready? Do it one more time. Do it one more time. One more time. Now go less than 31 pounds.
8, 9, 91. Oh, less than.
Less than 31. Don't count the 31s. So I guess just take out those 11, I guess, Madeline, right? You did 91. Just take out the 11 that are at 31. And you come up with 80. Yeah? Right? Now there's two ways you can do this. One way is we can add from the beginning to the up, but remember there's some clever ways to count too. 100% of the data is right in front of you. Exactly. You can just take these 3 bars and take those off the top. That's a quicker way to do it too. So that's 11 plus 8 plus, that's 20. Take 20 off the top, that's 80. Boom. Listen to this. 80% of the sample data is less than 31 pounds. 80% of the sample data is less than 31 pounds. We just figured out how much Max weighed during his appointment. He was in the 80th percentile, which means he's bigger than 80% of kids his age, his race, his gender. See what I'm getting at? That's the definition that is commonly used for percentile. I say commonly, I didn't say exclusively. That is the most common definition of percentile rank. Here we go. Here we go. That's the reason that he's in the 80th percentile. Here is the most common definition of percentile rank. It's the proportion of data some data point is larger than. Not necessarily the mode. Can be the mode. Not necessarily the mode.
Right, so I was just curious because they picked up an outlier at 33.
That's okay. That's okay. Outliers are part of data sets. Great, John. That's fantastic.
Okay.
And I would be more concerned with the ones on the other side, honestly, the 20 and 21 pound kids.
Right.
The 33 is actually pretty close to those high point peaks. It's the left tail that I'm most concerned about, but here's the deal. Assuming that sample was done proportionally in the population, those outliers exist anyway.
Right.
They exist. If anybody's interested in the normal occurrence of outliers in a population, that video I put up that's tied to the variation homework, the one that explains why the sum of deviations from mean is 0, I use a distribution there called the geometric distribution, which is freaking awesome. It's a crazy exponential looking thing like this, highly skewed, highly skewed. And if you hit F9, you watch the video and I'm refreshing the distribution and making new ones, little outliers pop up all the time. On average, they have to be there. An outlier isn't something that never happens. It's something that rarely happens. It can happen just very, very, very rarely. 1 in 100, 2 in 100 times. John?
I don't know. I guess my question is wouldn't you leave? I mean, if the highest outlier, the
Yes.
33, wouldn't you move the 100th percentile over and
I love
exclude that last?
I
outlier?
love that. John, say that again, just one more time.
Okay, so there's an outlier at the top that,
Yes.
that should be maybe excluded because of the 100th percentile.
Okay.
Should be just it's one person.
Sure.
That's out there on a
Sure.
3 pounds heavier. Or
Sure.
whatever.
But I don't think on percentiles that would work because it's saying if here is everybody, you are like the top 20% of everybody. Like that's all it's comparing is where you place
Just
that
the
in the
population
scale
size,
of everyone.
right.
Yeah.
Remember, this is a sample too, John. When you say move the top, I don't know where the top is.
Well, it's that outlier.
But in this sample it is.
Right.
What if there's a 36-pound 2-year-old in the population we didn't get in this sample? Then that 33-pounder's like, whatever, he's just a 33-pound kid. The 36-pound kid, my across the street neighbor was always huge until he hit like 2nd grade. Now he's kind of like caught up with himself, I don't know if that's the right word. But he was always this massive kid with this humongous Charlie Brown head. It's adorable. But he was always at the top of the percentile ranks because of that. But then all of a sudden, his body kind of caught up to him, if you will. Yeah, he's come to his age, I guess. And he's no longer at the 99.99th percentile. And that, you bring up a good point though, John. Thank you for the point you bring up, which is completely valid. I put however here, because this is not a uniformly accepted definition. There are other definitions. For example, let's back up to the data real quick. What percentile would a 20-pound kid be? Based on the definition I just gave you, which is the most common one.
3.
What percentage would the 20-pound kid be, literally?
3.
Literally, by that definition, wouldn't he be the 0th percentile? Because it's the proportion of data that a given data point exceeds. A 20-pound kid, who's he exceeding?
Nobody.
Nobody's to the left of him. He's at the far left. He exceeds no one. So technically, he's the 0th percentile.
Which I would say again for the 33.
Hold that thought. Please hold that thought, Madeline. You and John are getting to very, very good places. I love where you're getting. I love where you're getting. So technically speaking, he's the 0th percentile. However,
20-pound margin of error.
that's the other thing too. This is a sample. The 20-pound.
Well, 0 to 20 is 20, right?
Well, you're saying there are 0-pound 2-year-olds.
Yeah, right.
I mean, that's kind of freakish. And we'll come back to that. Not 0 pounds. We'll come back to malnourishment in a second. No, hold that thought, because this is where this is all going. There are formulas that, if you will, count, and you're going to analyze this on your second out-of-class exam. There are formulas for percentile rank that count those in a certain class as well as those below. So for example, a certain formula would say, well, there are 3 20-pound kids. Let's count that 3 as something and then additionally add on any data points below and divide that by 100. So he wouldn't be the 0th anymore, he'd be like the 1.5th percentile or something like that. Still very small, and in my opinion, you don't pick up that much by including it and it's confusing. So I'm just gonna call those guys the 0th percentile because it makes the most sense. Granted, it's a sample. Are there smaller kids than 20 pounds out there in 2 years? I'm sure there are.
Yes.
And they wouldn't be. Although there is going to be that one kid. There's that one kid that's the smallest. And that kid's the 0th percentile. And there's going to be the one kid that's the biggest. So, let me ask you a question. What's this guy's percentile right here? What's the 33-pound kid's percentile? Careful.
99.
He's the 99th percentile, right? Because who does he exceed?
Everybody.
Except himself. You can't exceed yourself.
Oh, okay.
Right? You can't exceed yourself. So that's why when you guys, some of you guys said ASVAB, Christina, you said, so who took the ASVAB, right? You never got 100% on anything.
No.
Not because we can't. Well, actually, yes, because you can't. You can't beat yourself. You're even if you're, well, okay. But if you're the highest person on that exam, you beat everybody else that took the exam, but you did not beat yourself. You only exceeded everybody else. So the best you can do is the 99.9999th whatever percentile. You can never be in the 100th percentile because there is no top. Because you can't be higher or heavier or head girthier or longer than yourself. Is that fair?
Yeah.
So that explains that kid out there. Now John, he might, in the population, this kid might not be the 99th percentile. He might be the 96th percentile because there's a 36-pound kid and a 35-pound kid. But in this sample, he's the 99th percentile. Is that fair?
Yes.
Good enough? Okay, good. Let's go back up. The reason I bring this up, let's come back to this. The reason I bring this up is during this checkup, when they saw that Max was in the 80th percentile for weight, the health practitioner asked my wife, what do you feed him? And my wife said, food. and the health practitioner said, well, what kind of food? And she started going through the diet, like, well, he loves broccoli, he loves apples, and he loves cheese quesadillas. So, cheese quesadillas, how often does he eat those? My wife was like, what the hell are you trying to get at here? And what they said, and this blew my mind, she said, any child that comes in under the 50th percentile for weight, we always ask questions to see if the child's being malnourished. And any child that comes in over the 50th percentile for weight, we ask questions to make sure the child's not on the path for obesity. And my wife, without missing a beat, said, so you ask every parent that comes in whether they're starving or stuffing their kids. Because every kid in that graph is either up or down from 50th percentile, except for the perfect median weight, correct?
Right.
And then the healthcare practitioner started stammering and stuttering, and my wife was like, you know what, it's cool. It's cool. Because what you're doing is, A, you're letting people like me educate you in statistics. And I'm like, I was never proud of my wife. This is the disease living with this guy all the time. And then she said, what you're probably doing is you're probably catching the kids that are being malnourished or overfed early on. But what my wife also said was, what you might want to do in the future, and this is brilliant, you might want to look at all the measures that you take and not just the weight. Because he's the 80th percentile for weight, he's also the 90th for length, and the 85th for head girth. So he's a proportionally big kid. If he was in the 80th percent for weight and the 15th for length,
Okay.
maybe we got a point. Maybe we got a point. Maybe we're then concerned.
Weight for size ratio.
Weight for size ratio, body surface area, BMI, although I hate it, you can measure BMI, you can measure body fat percentage. Please, Madeline.
I had a really similar experience because my son was in the 90th to 95th percentile
Yes.
until he hit 1 year, and now he's a really active kid, and he went from 95th to like 50th.
Exactly.
In a fairly short period of time, but it was just because he was suddenly mobile.
Hold that thought. Yeah, as soon
And
as
I
they get
had
mobile.
the same thing. They're like, oh, well, you don't know if we should be worried. I haven't seen the father. I'm like, he's tall and skinny.
Yeah.
Like,
You see pictures of my kid when he's 1.5 years old. He's a little pudge.
yeah.
Because he's crawling around. He's just starting to walk. He's got no muscle development. It's all fat. Then they start running around. And they turn into little string beans. I mean, well, I'll bring pictures next time, but you can see I plot his weather every 6 months. I take a picture of him in front of our front door in white t-shirt and pair of jeans, barefoot. And just watching 6 months to a year and a half. If you've ever been in my office, you've seen them. They're hanging on my wall. It's crazy to watch the changes. So to ignore that and to make an entire claim based on one statistic like that is the worst possible statistics. Because then what could my wife have done if she looked at the wrong way?
Oh no, we better not feed him any more quesadillas.
We better not feed him any more cheese quesadillas. We better shove all this other stuff down. What should we feed him? What should we feed him? And all of a sudden, you're forcing average on a kid who might be different from average in a little way, just by anecdote. He doesn't have to be at average if he's part of a distribution. That's the problem. So that's why I bring it up. So be careful. Be careful. Doctors don't always understand statistics, at least to the point they should. We'll come back to that too.
I'm really noisy. I'm waiting for a call from the CPS because I had a questionnaire thing where I was like, it's none of your damn business. It was something like, well, what do you do in your cases with your kid or whatever? And I wrote down, put him in solitary confinement.
Oh boy. That's like joking with TSA.
I'm waiting for a call.
What's in your backpack? A bomb. Yeah, get this one. Yeah. Careful with that, brother. Careful with that. Anyway, this right here. This is one of those ones I kind of didn't want to share with you at the beginning of the course because it didn't make a whole lot of sense. See if you can understand what you're looking at right now. FYI, it's the exact same data you just had, but it's given to you in a different way. See if you can figure out what it is.
Oh, yeah, okay.
Mm-hmm.
Everybody's at 33, almost everybody's at 32. Maybe less.
Good. Now, listen to what Madeline just said. Everybody's at 33.
Or
See,
below.
That's the
It's
kicker.
cumulative.
It's a cumulative count. There were 100 kids in that sample, remember. 100 of the 100 are either 33 pounds or less. 32? Almost all, we'll call that 98 or 99, I can't exactly tell, are 32 pounds or less. What's an easy one to see? Oh, this one, or this one, I guess. 30 pounds. 80% are at 30 pounds or less. That's why it's so easy to find max on this, isn't it? It's even easier to find him on this than it is to find him on the previous one, because if you know he's in the 80th percentile, that means you want to know what cutoff it is between 80 and, say, 81. So you find 80%, you come across, and it says, oh wow, 30 pounds is the cutoff for 80%, which means max must be just above that, or 31. That's why it's called a cumulative frequency histogram. So you see how it's still a histogram, but it keeps track of a running total. So you see, originally, there's your first 3 kids, or whatever. I think it's 3 kids in the beginning.
Yeah.
Now, it doesn't go down like the previous histogram. Drop down. It goes up because you're adding 3 kids plus that 121-pound kid. Then you add 1 or 2 more 22-pound kids. So in other words, this is never going to go down. It might level off. If there's nobody in a particular class, it would just stay level because you're adding 0, but it can never drop back down again. John, go.
I just think it's kind of weird that you can have 65% to 90% a percentile with 2 pounds.
Brother, I love what you just said. What John is commenting on, and I love this, is the steepness of the curve right here versus the shallowness of it down here. Remember the raw data set though?
Mm-hmm.
How packed in the data was right here? That's why those are jumping like they are. You're adding 15 data points to this one over here, whatever this one was at. You're adding 15. So you're adding, if you will, 15% of the data set onto the previous bar to get the next bar, which is why it jumps like it does. John, I love what you just said. And that's why you see this humongous jump right here, right?
Right, so if a doctor used this, they'd be off terribly.
They could be, and that's why they get a little bit more. I want to come back to that. Give me 30 seconds. What often is used, because of what John just said, is a lack of precision. We get accuracy, as Tim mentioned before, but we lose precision sometimes. So a lot of times, what they'll do is they'll just connect the tops of these and make what's called an ogive, which is this. Now, John's going to say this is actually less precise than the previous one because now we have no reference point of the bar. Great, taken, point taken. That's what an ogive, I don't know why it's called an ogive. I'm not exactly sure, but it's like the one, it's weird. You have like frequency histogram, relative frequency histogram, cumulative frequency histogram, ogive. Like I don't know where this came from, but whatever, that's what it's called. Here's the ogive doctors use. That's what they use. As crazy as this looks, it's actually amazingly easy to use. Yeah. And you get a lot of precision here. And John, I'm not saying that doctors are on. When they're measuring his weight, we're doing this backwards, just so you know. When your kid goes to the doctor, they don't eye up and go, 80th percentile, then put them on the scale. They put them on the scale, then tell you the percentile he's in. Does that make sense? Yeah. So the first thing they do with Max is they slap him on that little scale, they measure him, they see what he weighs. Then, once they know what he weighs, they use this chart. So let's figure this out. Birth to 36 months for boys, length for age, and weight for age percentiles. Okay, so let's figure this out. Birth, 3, 6, 9 months, 12, 15, 18, 20. There's Max, 24, at least at this checkup, he's 24. Now these go out as far as you need them to go. You can Google them and find other ones. So 24 pounds. What we had to find is, where does he fall on 24 months? 24 months, where does he fall percentile-wise? Well, he was 31 pounds. So you come over to here to weight, and one of these is in kilograms. That's kilograms, there's pounds. You go to 31, right about there. Follow me here. We're going to bring this guy across and intersect. Ish, right about there, right?
75
right about there. Now notice where my finger is. These are the percentile markers. Right? There's 90, there's 75. This one's roughly a third of the way from 75 to 90. They called it 80. So they're ballparking with the 80 percentile. It's clearly above 75. It's clearly below 90, and it's a little bit closer to 75 than 90, so they call that 80. Is it exactly 80? I'll have you guys calculate that by the end of the course. I'm going to have you calculate his most recent percentile for his 6th birthday, which I'm going to get back relatively soon. So you can actually get way more precision this way, John. I'm with you, but this takes care of some of that. But here is why, Madeline, you mentioned your child was always at 99th percentile when he's very, very young. Look at these percentile bars. They shrink down very, very, very tightly when children are very, very, very young. Imagine if somebody does a measurement and they're off by ½ pound at birth, or even 3 months later. You're off by ½ pound. That's the difference between, say, the 50th percentile and the 75th percentile. Whereas it's not a difference at all over here. So sometimes those things, not if you see it over and over again. If you see repeated 99, repeated 99. As a fat kid, it's okay. I don't mind.
Like double chin.
It's okay. They all do.
Fat around his
like the Michelin man when he came home. Like, that's my kid.
Seriously.
No, it looks just like you.
Everywhere.
So there's that, but there's also the fact that you can be off by precision just because these are so close together. And as the children get older, these just keep getting wider and wider and wider because of natural variability in body types. It just happens. And the chart allows for that. Kind of rad, huh? Kind of cool. And you've got the heights up top, the lengths up top, so you can find Max up there if you want to. And I'm going to keep revisiting Max because it's one of those things. It's a perfect application of percentiles, and we'll keep coming back to him as we go through the course. Make sense? Ish? Getting there? Now, the difference between the chart you're looking at here and the chart you're looking at here is that's based on a sample of size 100. This is based on tens, if not hundreds, if not millions of measurements of babies. I put a lot more stock in this. Because this accounts for those 33, where's 33-pound baby? 33-pound baby right here, right?
Yep.
At 24 months of age?
Is a big kiddo.
Right, but check it out.
The 95th is still above it.
He's below the 95th percentile. So that means there are some bigger kiddos. There are some bigger kiddos. Here's something else to think about. Here's something else to think about. What if your kid clocks in at 38 pounds at 24 months? So it puts him about here. What do you call him?
Samoan.
The Samoan. Nicest people I've ever met in my life, by the way.
Yeah, really sweet.
Visited Hawaii, met some Samoans. I'm like, my God, you
They're
are as
big.
big as 3 people, and you give the best hugs ever. Can you do that again and crack my back? Thank you, Gideon. His name is Gideon. What a great name. What do you do with a 38-pound kid? What do you call John?
Don't they go like 110?
Careful, they do, and that's terrible mathematics.
They do? I didn't even know they did.
You can. I have heard this over and over again. Children being marked as 105th, 107th percentile. That is meaningless. That means you exceed more data than there actually is.
Yeah, that's ridiculous.
It makes no sense.
I've heard of that.
What they're doing now, I'm going by what I think they're doing because I can't find an answer to this anywhere. A lot of times when they say the 107th percentile, for example, is you're bigger than 100% of those at your age, and 7% of those in the next age group up.
Okay.
That's bad math, though, and here's why. I mean, I know all you said, oh, and it makes perfect sense when you hear that, right? But here's why it doesn't make sense. If it's okay if I can, I don't want to burst your bubble, but it doesn't make any sense because.
Still in the age group.
Okay, so here's age on this block here. Here's age 2. Here's age 3. Okay. Oh, thank you guys. Thank you. I forgot about that. I gotta get the GPS chip. Here's age 2, here's age 3. I'm going to make this bell curve data just because I know it's skewed by our sample, but let's pretend it's bell curve just for our sake of argument. There's 2-year-olds. Here's 3-year-olds. Okay? So you're saying he's 107th percentile because he's bigger than all of these and also the bottom 7% of this curve. Well, the bottom 7% of this curve is in this curve already.
Yeah, that's true.
Right? The smallest 3-year-olds are as small, or if not smaller, than some of the medium 2-year-olds.
Right.
The curves don't, what doesn't happen, because this is what you think in your mind, what doesn't happen is this.
Right.
That's
right.
not 2, that's not 3, that's not 4. There's overlap in the curves.
Right.
So what does 107th percentile mean? Hell if I know. I can't find any explanation for it. Not to mention the fact that it doesn't make any sense. So, what you do, and what I'll have you do as the course goes, you can swing that back if you want. When you get to the 107th percentile eventually in this class, I'll have you, or excuse me, when you get to a kid that's off the charts, I'm not down, he's off the charts, he's off that chart. But he's not the heaviest kid most likely in the world. I'm sure there's a kid heavier.
Right.
The question is, how do you then measure those outliers? We'll get to it, I promise, as we refine our study of the bell curve in this class and get more and more precise and specific. But not right now.
Okay.
Not right now.
Okay.
Now I need new data. I think you're getting tired of this weight data. So here's what I want you to do. Take that data sheet I gave you. Some of you have already done this. Very lucky. I want to know how many states you visited. I want to know how many states you visited. I've given you a map to help you. I apologize for the size of Alaska and Hawaii. Alaska is way the hell too small. Alaska is like as big as, I think it's like 40% of the United States, the contiguous United States. It's humongous. It's embarrassingly small in there, but I couldn't get the damn thing to fit well any other way. Let's count a visit. If you've actually driven through a state, count that as a visit. Driven through, even if you didn't stop, if you've driven through it. If you've flown into a state, count that as a visit. Because chances are if you flew into a state, you probably stopped and got off the plane, walked around a little bit. Don't count flying over a state. You have to actually have, physically touch the ground in a state to count it as a visit. Okay? Have at it. Let's collect some data. Look at you.